So unfortunately, these notes are not related to probability whatsoever. I'm pretty confident the reason we do these now is because this is our last test before you take the SAT, which is in under 2 weeks from now, about a week and a half. So we need to review kind of the essentials of our three main functions: linear, exponential, and quadratic. We did first talk about these back in Unit 2 first semester, so you already have a bit of experience with them, but there's just a little more that we need to cover about it. First off, linear. Remember, linear has the word line hidden in it, as in a straight, nice, solid line. That's how you'll know you have a linear function, if you have the graph. And it will be going up to the right or down to the right. And just to get a tad more specific, because this will come in handy later, the first representation I have here, this is the positive, and then on the right side, this is the negative, as in slope, positive slope, negative slope, going up, going down. Pretty intuitive. For the graph, it's just going to be a visual where we'll use it in a moment. But the equation, I'm going to write it again just to really emphasize what the equation of a linear line looks like. Linear graph. Y equals 3x plus 2. You should recognize that y equals mx plus b form. Now for the table, we're going to fill out the table using the graph. First we have x and y. Our first point, and a couple of these are hard to see, so just a warning there. Our first point is -1, -1. Our second point is on the y-axis at 2, 0, 2. Third point from there, again, it's kind of hard to tell, but it's at 1, 5. And the last point is at 2, 8. The reason we focus on the table, there is a way to tell that this is a linear function based on the table alone. So if I didn't have this graph, I could still figure out that this is a linear function. There is a pattern in the y values. When you're given a table and asked to look for the pattern, the x's will always go up by 1. They have to in order for you to see the pattern in the y's. So don't look at the x's to see the pattern. It's going to be the same. Let's look at the y values. So you go from -1 to 2. -1 to 2, that's a change of +3. 2 to 5, that's still a change of +3. We can see a clear pattern being established here. And once more, 5 to 8, we see a change of +3. The pattern for a linear function is addition or subtraction. So if that's what's going on in your numbers, you know you have a linear function. Next, let's move on to exponential functions. The SAT loves to put one of these on here, so it's a good idea to take another look at them. Exponential, they have this kind of curved shape that you can see in the graph. The top one that I drew that's going up to the right, this is the positive graph. And then the one on the bottom where it's going down to the right, that's the negative graph. Just for reference. Again, I'll rewrite this equation below just so we get an idea of what an exponential equation looks like. F of x equals 2 to the x is what that says in the image. Quick reminder, what does this f of x stand in place of? What's it represent? Yeah. Yes. So remember, anytime you see that f of x, don't freak out, it's just y. That's what that notation represents. I could have written this equation as y equals 2 to the x. They're the exact same thing. Let's do that same exercise again with the table. Our first point is at -1. You'll just have to take my word for it on this one. This is -1, 1/2. Next point hits the y-axis at 1, 0, 1. Next point, 1, 2. Final point is at 2, 4. Let's look at the pattern. If you're not comfortable starting with the fraction, we can start at the 1 and we'll go back. So 1 to 2, that could be 1 plus 1 or 1 times 2. This is why it's important to check multiple numbers because there's a couple of possible patterns. Now clearly it's not going to be 1 plus 1 because that would be a linear function and we know this isn't linear. So the pattern is multiplying by 2. 1 times 2 is 2. 2 times 2 is 4. And if we go back to our first number, 1/2 times 2 is 1. And if we kept going, you'd see the clear pattern. On top of that, if when you go from number to number, you have to add different numbers, that's not a pattern. Just an FYI. It has to be the same exact thing happening. As you can see, our pattern here, it's multiplication. To cover my bases, or division, those two do go hand in hand. I don't anticipate that we will throw a division problem at you. Those are a little harder to tell, but just put it on your radar. If it's dividing, it's still exponential. That would be the negative version of it. Last one is quadratic. We have had plenty of experience with these. Quadratic has the U-shaped graph, as you can see. Again, the top one where it goes up is positive, and the bottom where it goes down is negative. What do we call these U-shapes, by the way? Parabolas, thank you. So this graph does not have the equation on it. I will just tell you what the equation is. Y equals x squared minus 4x plus 3. Let's fill in the table. For you to really see this pattern, I have to give you 5 points, so I will be going 1 extra underneath, just letting you know that. My first point is going to be where it hits the y-axis at 0, 3. My next point is at 1, that's 1, 0. Third point, 2, negative 1. And while we're talking about this specific point, what's the name of that point specifically on the parabola? The vertex, thank you. The very bottom of the U of the parabola or the very top of the parabola, that's your vertex point. 2 more points. 3, 0. Like I said, we'll go one more. Four, three. Quadratics, they have a very unique pattern. So if you try to go from one number to the next, you're going to get kind of lost. This isn't a pattern that you can calculate. It's a visual pattern. You look at it and you see this pattern happening in the table. Does someone see what I see? Just looking at the y values, what's happening here? It's mirrored. That's exactly what I'm looking for. So if you look on the graph, and this shouldn't be a surprise, this vertex, we could put the axis of symmetry through it. We talked about that in previous units. It cuts the parabola in half at the vertex, so then the left and right sides match. So that repeating number should not be a surprise at all. So the vertex is the middle of this repeating pattern. It's the one number that won't repeat. All the numbers around it will repeat. If we keep going up and down on this table, that same thing is going to keep happening every single time. So if we go one up, one down, we have the same number. If we go up and down again, we have the same number. This will keep happening. So this pattern, you can call it a few things. First off, the pattern itself we refer to as symmetry. And I like the answer Dorothy gave me. Mirrored is great. Like a mirror, that's a very obvious way to describe it. So that's what we're looking for. We're looking for that curve effect happening here. Questions over the essential three functions? Next page. Let's see how many of these we can get through. Determine which type of function is depicted in each table below. Your answer can be linear, exponential, quadratic, or neither. So you're looking for the pattern. Now we don't have the equation, we don't have the graph to look at, we just have the table. Find the pattern. Number one. And reminder, we're looking for this pattern among the y values. The x values go up by 1. You can clearly see that. So let's look at the y values and see what's happening here. 5 to 10. There are two possible patterns here at this first number. 5 times 2, that's 10. And 5 plus 5, that's also 10. This is why we need to go multiple numbers to establish, because only one of those is going to be right. Let's go 10 to 15. Well, 10 times 2 is clearly not 15, so that's not going to be the pattern, but 10 plus 5 is the pattern. 10 plus 5 is 15. So plus 5, we've got two good numbers. My advice, go at least 3. Make sure. 3 will ensure the pattern. 15 plus 5, that is 20. Our pattern here is addition. This is a linear function. Number 2, again, we're checking the y values specifically. And I forgot to mention, when you do start these problems, do just a quick look over and see if this might be a quadratic where you have those numbers mirroring each other. That's a really easy way to eliminate an option. Clearly that's not happening here. All of these numbers are different. So we'll go through and we'll look for a pattern, a calculation that repeats itself. So 10 to 7, so there's really only one way for that to happen, and it's minus 3. 10 minus 3 is 7. 7 to 4, that's minus 3. One more. 4 to 1, that is minus 3. This is subtraction. Which is also linear. Reminder, linear is addition or subtraction. Number 3. Again, look at the y values. Make sure that that mirror isn't happening. That's clearly not the case. We notice that our numbers get big quickly. That is a giveaway of an exponential function when the numbers get large very fast, because multiplying obviously makes numbers bigger quickly for the most part. So 3 to 6, 3 times 2 is 6. Again, I could consider 3 plus 3, but I've already explained why that's not going to be the case. 6 times 2, that is 12. And then 12 times 2, that is 24. We have a clear pattern here, a clear pattern of multiplication. We have an exponential function. Last one, number 4. Again, do a quick look over, see if that mirror effect is happening, and it is. We have 2 negative 3's that are equally spaced apart, and we have 0's equally spaced apart. In the middle, we have the one value that doesn't repeat, 4, but then the numbers around it do. So we can connect them with curves like that, kind of like a rainbow. This is clearly a quadratic function. So again, the pattern here is symmetry. We have a quadratic function.